The CIRAS-4 portable photosynthesis system can change CO2 gas concentration while simultaneously and continuously recording data. Linear ramps of CO2 concentration are easier to program and record than in previous instruments, and now that there's no longer a need to define a response script for a ramp test in the CIRAS-4, the process is faster and more streamlined than ever. Follow these simple steps to create ACI curves with the CIRAS-4 in minutes. We begin by performing a stored Diff calibration to allow the CIRAS-4 to have accurate offset information applied continuously throughout the linear ramp. Install fresh desiccants and a new CO2 cartridge in the CIRAS-4 and allow it to warm up for 30 minutes. Navigate to Setup, Calibration, Stored Diff and tap Start. Beginning at 0, the CIRAS-4 will step through 6 CO2 levels between 0 and 2,000 micromoles per mole, and 6 H2O levels between 0 and 100% of ambient humidity, performing a diff balance at each level. It then computes a regression analysis of the resulting offsets that will be applied for every CO2 concentration in real time. The stored diff balance calibration takes approximately 12 minutes and must be allowed to continue to completion. Tap the Accept button to complete the process. Next, let's set Zero Diff Bal mode. Navigate to Control, General. Tap the Zero Diff Balance Mode button, select Zero Stored Diff Bal, and save. Next, we'll set the ramp criteria. Ramps in the CIRAS-4 always begin at the current control setting of CO2 as shown on the measurement CO2 tile and return to that original CO2 value when the ramp is complete. A typical ramp for a C3 leaf might be an increasing ramp, starting at 100 micromoles per mole and ending at 1100 micromoles per mole with a ramp rate of 180 micromoles per mole per minute, for a total experiment time of 5.3 minutes. To set the ramp criteria, first navigate to Measure, Photosynthesis, and tap the CO2R tile. Set the starting CO2 for the ramp to 100 micromoles per mole. Next, navigate to Control Ramp. Be sure the direction is set to up, the step to 180 micromoles per mole per minute, and the upper limit to 1100 micromoles per minute. Next, let's set PARI. In this example, we're working with basil, which requires PARI to be 1200 micromoles per meter square per second. Now let's set the recording options for ramp processing. Navigate to the main measurement screen, Measure Photosynthesis, tap Record Options, tap the Enable Ramp toggle so that a 1 is visible indicating that it's enabled. The interval will default to 1 second. Tap the data file name white box and enter a file name, and the comment box for any relevant notes. Then tap Return. Next, let's perform the empty leaf ramp. The first ramp recording creates the baseline trace to characterize the time response of the system and stores the data for subsequent post-processing. With the closed cuvette, tap Start on the command menu located to the right to begin the ramp experiment. Use Measure Graph or Measure Photosynthesis to switch between graph and tile views while the ramp is ongoing. You can also monitor the progress of multiple parameters throughout the process quickly and easily. Once the linear ramp is complete, an additional 30 seconds of data are recorded and the CO2 control will return to the initial lower limit. Next, we'll perform the ramp experiment with a leaf in the cuvette. Tap Record Options on the command menu and enter a new file name and comments as in Step 4, and tap Return. Now, with a leaf in the PLC4 Universal Leaf Cuvette chamber, tap Start. As you watch the plot of A versus time for the ramp with the leaf, it becomes clear when CO2 saturation occurs, at which time the ramp can be terminated by selecting Stop. You also have the option of letting it run to completion, in which case an additional 30 seconds of data will be recorded automatically. Either way, once the ramp is complete, the CO2 control returns to the initial setting and is then ready for the next ramp experiment. Next, we'll transfer data files to a PC to begin post-processing. Insert a USB flash drive into either slot on the back of the CIRAS-4 console. Tap Transfer Files on the command menu. Highlight the data files recorded in the previous steps and tap the Transfer button to move the files to the USB drive. The CIRAS-4's stored diff balance capability makes post-processing very simple, all done in Excel simply by adding 3 new columns to the standard CIRAS-4 output file. Simply open the CIRAS-4 ramp post-processing spreadsheet along with the 2 ramp data files. Copy all data from the file with the leaf in the cuvette, columns A through AN, and paste it into the CIRAS-4 post-processing spreadsheet. Next, copy data from column AB, assimilation A, from the empty cuvette ramp spreadsheet and paste that data into column AO, empty A of the CIRAS-4 post-processing spreadsheet. Copy the formulas in columns AP and AQ down all rows. The actual assimilation rate is computed in the column AP after a brief lag period, typically at about line 20. The substomodal CO2 concentration, CI, is now recomputed in column AQ, using the new actual assimilation and the other values that have not changed. Next, plot A versus CI starting at about line 20 after the linear ramp stabilizes. Download the application note for tips and additional sample results. Contact us today to schedule a virtual demonstration of the CIRAS-4 portable photosynthesis system. Visit ppsystems.com.